Okay, guys, so here is phase 10, and the practice for this is on delta math. So a definite integral is written like this. It looks like an antiderivative or a regular integral, except there are numbers on the bottom and top of the integral sign, okay? And what this means is the area under the curve f of x over the interval ab. All right, so whatever the interval is that you want to find the area under the curve of, you put those endpoints there. Now, by the area under the curve, this is what they mean. So by the area under the curve, what they really mean is the sum of the areas of the regions formed by the graph of the function. That is the curve. The graph of the function is the curve and the x-axis, okay? So in this context, the area can be positive or negative. Guys, just watch me for a little bit while I show you some things, okay? So this is, all right, so this is the graph of sine of x, all right? This is the graph of sine of x. This is 0, and then here I have 2 pi, all right? Now, I want the area under the curve. Let me find the area under the curve from 0 to pi, and I'll show you how to use your calculator later to do it. So we go to calc, so second trace, and then down at the bottom, so 7 is this integral right there, okay? The lower limit is the number that you want to put at the bottom of the integral. So the lower limit is 0, enter. And then the upper limit is the number you want in the top of the integral. So I'll do pi. And watch what it does. So it shades in that area. So the area under the curve from 0 to pi means the area of the region, Walter, the area of the region formed by the curve or the graph and the x-axis, okay? And you can see here that the area under that curve, that's actually 2 units. Okay, now let me do the area under the curve from pi to 2 pi, okay? And then you could see what goes on there. So, okay. All right, so same graph. Okay, so now from pi to 2 pi, so I go down to 7, lower limit pi, upper limit, I should have put him in the room. And then you see that, but guys, the area is -2. So if the curve, let me put Walter in a room. If the curve is below the x-axis, then that's going to be a negative area. Okay, so Walter's shut away now. All right, let me just show you 2 more little things, okay? Let me do the area under the curve now from 0 to past pi. So I'll do from 0 to 3 pi over 2 or something, or 3 pi over, or let me figure it out as I go. All right, so okay, so I'll do the area under the curve from 0 to, I want to go past pi. So I'm going to have some positive area and some negative area. So I'll do 7. All right, so I'll go 0 lower limit, and then past pi, maybe 5 pi over 4 or something. So upper limit 5 pi over 4. Okay, and you could see, guys, we already know from a previous thing that this area above the x-axis was +2. And then this is negative area here. So we had this positive area, but now it's the total area is starting to decrease when we pass pi because we're adding on now a negative area. So here, we had positive area, and now the area starts decreasing as we move further right, and then it would start, the total area would start increasing again if we moved past 2 pi, because then it would be positive. Okay, just one more thing for fun. Just because it's kind of interesting. Maybe, I think you already know. But I'm going to do this, but try to think of it. What's the area going to be from 0 to 2 pi? So think about that. I bet you already know. So 0 and then 2 pi. That area is 0, okay, because this was positive 2, that was negative 2. Okay, now, so here we have some cases, guys. A positive integral. The curve, okay, so case 1, you'll have a positive integral if the curve is completely above the x-axis over the interval. Okay, so this right here, this means this definite integral, it's called, it has numbers on the ends, is the area under the curve of f of x, the area under the curve f of x from a to b, on the interval a to b, and this is a positive area, curve completely above the x-axis. Or, you kind of just saw this in my calculator, the area above the x-axis is greater than the area below the x-axis, okay? So, the area from a to b under the curve is positive. The area under the curve from B to C is negative, but this positive area is bigger than the negative area. So the total area from A to C under the curve is going to be positive. Okay, now here is something kind of interesting, guys. Oh, actually, let me show you this. All right. I can't even think. I'm going crazy from being inside. I gotta take a walk today or something. Okay, so guys, what if I do, all right, so we already saw, let me just write something down. We already saw from my calculator that the area under the curve of sine of x, okay, this is the sine graph, from x equals pi to 2 pi, we already saw that that was negative 2. All right, that from pi to 2 pi, it was this, the curve was below the x-axis, that was a negative area. But watch what happens if I make it a backwards interval. So instead of integrating from pi to 2 pi, I'm going to integrate from 2 pi to pi. So it's the same length interval, but it's where the direction is different. It's a backwards direction, negative direction. So I go like this, 7, 2 pi, 2 pi. Well, it fills it in frontwards still. But that is a positive 2. But guys, you say, oh, that's a negative area, and we get positive 2. It's because we integrated backwards. The interval was a backwards interval. Okay, so anyway, this is the third case we're having a positive integral. The curve is completely below the x-axis over a backwards interval. So instead of from a to b, from b to a, the integral from b to a. Now, a negative definite integral, guys, you kind of just like, reverse the top stuff. I won't read it to save time. Here completely below the x-axis, here the area below is greater than the area above. Here, the curve is totally above, but we're integrating backwards from B to A. Okay, now, I've talked a lot, but this will go fast now. So state whether the values of the integrals below are positive, negative, or 0. Okay, so I'm going to use colors. I guess I'll use pink and orange, but maybe they're too similar. Orange, yeah. Orange and blue, I guess, but I'm on blue paper. Okay, so this is the area under the curve from A to B of f of x. So we're just assuming that this is f of x. Oh yeah, so from A to B is this area. Guys, that is less than 0. That's less than 0. It's case 1. The curve is completely below the x-axis. It's less than 0. All right, now let's do this one from A to C. Okay, so from A to C, I have like two areas. I have from A to B, which we already know is negative. And then from B to C, okay, I'll make the positive ones blue. So the question is this total area positive or negative? It's positive because that's case 2. The area above the x-axis is greater than the area below. Now let's do from C to B. Okay, so from C to B, this is, all right, so from C to B, all right, this is a positive area, but we're integrating backwards, C to B, C to B. So it's a positive area, but since we're integrating in a negative direction, it's like a positive times a negative. You think of it that way. So this would end up being a negative. And now let's go from C to E. And guys, I made this purposely. If something is bigger than something else, I would have made it like super clear. But okay, so from C to E, I got to do C to D first and then D to E. And I try to draw the picture so that these look like equal areas. And let's assume that, let's say that they are. This negative one and this positive one, they would just end up canceling because they're the same. So that would be 0. Okay, now on delta math. So you're gonna practice on delta math, and I'll do an example. Given the function f graph below, determine which of the listed integrals is less than all of the other 3. Okay, less than all of the other 3. So first from 0 to 4. 0 to 4, that looks to me like maybe a 0. Like that's like the area here from 0 to 4, that looks to me like maybe that would be 0. Because I think that's a positive area. That looks like an equal negative area. So maybe I'll say here like about 0. I think it is 0, but at least very close. Like these would cancel each other out, those areas. From -7 to 0. From -7 to 0. So we've got this positive area. We've got this positive area. And I think it's safe to say this positive area is bigger than this negative area. So it'd be -7 to 0. I think this positive area is bigger than that negative area. So I think this is greater than 0. I'm going to say but small. Yeah. Now from 2 to 4. From 2 to 4, that's totally negative. Now from -2 to 4. From -2 to 4. Oh yeah, for sure that's negative because we've actually got 3 sections. Since this is the last one, let me draw. From -2 to 4, I've got this negative area. And I've got this positive area. And then I've got this negative area. All right. And the sum of so the total area is the sum of all these 3 areas. And we have more negative area than positive area. So that's for sure negative. Okay, so the answer is this. Please get in touch with me. Text me, email me if you have any trouble with this, and I could make you your own little video if you want, or we could just do a Zoom chat or something. Okay, if you want. All right, I'll talk to you later. Make sure you do delta math. Bye-bye.